Recording now.
Okay, everyone, this is the Container Identity Working Group meeting for August 25th. So I, just before this meeting, shared out a meeting notes and agenda doc with the group, so everyone should have edit on that. I put the stuff that we had from kind of decided on from last meeting to talk about in here, which is kind of the second point. And I thought we would start by just kind of, we talked over a bunch of kind of goals and use cases last time, and we kind of got into a bit of design discussion. So I thought we might just review goals and use cases quickly and see if, give people a chance to speak up about, if they come up with any others. In the meantime, the mailing list was pretty quiet. So then there might have been stuff that people wanted to discuss but didn't get around to putting on the list. And then open it up to basically where we left off with the discussion last time, and using that identity design doc as kind of the seed for that discussion. So Clayton has some comments in here that I haven't actually managed to accept. I should just do that. But these were the kind of more specific goals for, so we had some working group goals, and these were kind of the sort of container identity goals, kind of more specifically that I came up with. And I'm not sure if it's actually worth kind of reading through these now, but if people have comments on this, maybe we'll just throw it open now to talk about if people had comments on the goals. Okay, I'm going to take that as a I'll comment in the doc, or I think these are okay. And we also wrote down some non-goals here too. So some of the stuff that came up last meeting, so authorization, we're going to keep out of scope. There was some discussion about kind of how you would do alerting and that kind of stuff. We didn't maybe write that down here. I think we wrote it down in the working group goals. That one's out as well too. Yeah, that's probably enough on the goals. And so this is the use cases we'd written down. I'm not going to go through these because I went through these last time, but I'll just open it up again to see if anyone wants to talk through a use case that isn't well represented, or they think needs to be added or needs to be changed.
I think like an important question would be, I think we want to do a really good job of making sure that we'll all get use cases brought up and that we clearly go through it. If there's a preference for how we reach, these are the use cases and the agreement, I think what we should try and do is, if we think we can get to general consensus on what the use cases are via the call, let's do that. If there's some concerns about, wanting to have time to really go over this in details, maybe we should set a goal via the mailing list to say, like, here's the proposed ones from the last meeting, and then we want to ratify these by the next meeting. Or come up with a deadline just to kind of for each of these things to give us a sense of progress through it. It worked well for the resource management working group.
Yeah, I think so. And I was also thinking, should we identify an area where we should be checking these things in, maybe, rather than, I don't know if we want to do that or if we want to leave them in Google Docs. But.
I do think we probably want to put the use cases and the goals and non-goals into a more concrete form. I think the resource management group had those actually checked into something under their SIG goals. Like in terms of like general working groups are supposed to have kind of a charter of what they're trying to accomplish. And so I think being formal about that would be good. So we could move it into a PR to the community repo, do formal comments there.
Yeah, I think that's a good idea. Okay, so then sort of the rest of this doc is basically presenting a kind of decision point of, well, it's presenting two things. So like it's considering whether we can do X509 for service accounts, which is kind of like a bit of a perhaps implementation detail at this stage. But it's a, should service accounts be pluggable with multiple different types? Should there be this base identity for Kubernetes that you then exchange for all other identities via an identity exchange? And kind of this is where we left off the discussion last week, and I wanted to kind of get back to that. So I think we need to identify kind of what the integration points are here. Is it service account? Is it like a pluggable service account? Is service account JOT always the gold standard for Kubernetes identity, and then you need to exchange that for something else via some exchanger? Or is there a completely different model that we should be considering? So I think it would be good to have some discussion around those kind of points here.
So I'll say that it would be much easier to use these identities if you don't have to, if the workload doesn't have to do anything in order to get access to them when it comes up, if they're just kind of there and ready to go when the workload actually starts. So whatever solution we do, whether it's Exchange or some other way that you're plugging in these identities, it's a real pain if that's not sort of ready to go when the workload starts, because then you have to deal with that in the workload itself.
Yeah, I think that's a great example. I mean, that's why service account tokens, in a sense, exist for the API. And that's why pods wait for secrets to exist before they start, is to reduce the barrier to, like, it's not just about giving people access to secrets or giving people access to an identity. It's about making it easy to use in a predictable, reliable way, while still having the ability to go do the advanced use cases. And like that, maybe that's like the difference between what we would say, like, what are Kubernetes goals out of this, is to make it easy, useful, and extensible, / you can, the 80% gets easier and the 20% is possible, or something like that.
I think it's nice to have credentials available, immediately at init, except that you still probably want to handle rotation, which introduces pretty much all the complexity that you would have to initialize and wait for secrets. You also get if you have to watch and reload. So that might be another decision point, is whether we need whatever credential we generate, whether we want to put a short TTL on it. And if so, I think that means, that the API that the workload uses, that the pod uses to get its credential, is probably more complicated than just a file on disk. Or if it is a file on disk, it needs to have a contract where you need to be watching that file and reloading every hour or whatever.
Is it reasonable to say that we might want to make it a goal to tie, like, if you ask for a credential in kind of the naive case, our goal should be to get you a credential that's paired well with your lifetime, such that you don't have to think about that. Like, that we kind of, I think this is in a little bit of the doc in some places, but maybe not called out explicitly, that it's really hard to do. It's really hard to do rotation right. It's a lot of code. And if we can do it in a way that the availability of the app is something that the platform is helping manage, like staggering restarts, there's some angles there that we could say, like, maybe we don't do that as a first pass, but we say it should be easy to, if you define a token that has a lifetime, your application gets restarted every lifetime. It's hard to coordinate that across nodes, so that's maybe one potential wrinkle there. But there's some advantages to saying like you shouldn't have to think about rotation most of the time unless you want more control over the process.
There's a related thread somewhere in an issue about signaling processes whenever config maps reload. That's hints at basically all the same problems.
So are we making a distinction between the identity that gets initially assigned to the workload and the additional secret that customer, in addition to the initial identity assigned to the workload? Because I think for general secrets, I do hear use cases around rotation, and people want to inject secret only when it's needed. So not necessarily at the start of the workload. But for workload, for identity, a workload may want to have the consistent identity for the duration of its lifetime. So I think it will be reasonable, as Clayton pointed out, to refresh it every time the workload restarts. But for secrets, it may have a shorter time. Do we want to make a distinction there?
Wait, are we saying that we want the identity to be consistent, or we want the actual cert and key to be consistent?
Right. So I guess my question is, are we treating all the different types of credentials the same, or are we saying that there will be one sort of bootstrap identity that can be used to exchange for additional types of identities, or are we saying that it doesn't really matter what it is? We're just
I don't think we're going to have. I don't think we're going to say there's one that you exchange for all others. I think starting with one and exchanging it for others is a pattern that we want to support, but I don't think we're saying that the Kubernetes API container identity is the one that you then exchange for everything else. I think there are two types of interactions. There's the sort of dial tone interaction where as soon as I come up, I just have this credential here that represents my identity, and it is given to me automatically. It's maintained for me automatically, either by renewing it and putting a new file on disk, or renewing it and sending me a signal, or by terminating me and restarting me when it needs to be renewed or rotated. All three of those are kind of different mechanisms that you could use to maintain that. But the dial tone attitude where it just is, that's one approach that I think we want for Kubernetes. That's what we have basically with service account tokens now. We'd like that to be stronger with X509 types of things, and then renewal comes into play. We want to support the same type of thing for other providers, right? So if you have a Kerberos provider or you have a Vault token, we want to support those mechanisms, injecting and maintaining those credentials in a similar way that we would for the Kubernetes credential. And then just like you could take the Kubernetes credential and use that to exchange for other credentials, you could take your Kerberos ticket granting ticket or your Vault token, and then the container could actively use that to go exchange for other things. So that's where the container is actually participating in obtaining the credentials, further credentials.
So
I think the approach
perhaps
we have for Kubernetes, we want to make sure will work for other things as well, but not tie those other things to the Kubernetes identity.
So perhaps I can suggest an approach that brings together what you suggested and what Sandor suggested. So in discussions we had in Google around this, we were trying to figure out a way to solve this for both Kubernetes and Istio. And I think what Sandor was alluding to is that we felt that from a security standpoint, we need to separate ideally a bootstrap identity, which should be ephemeral and can come from any identity providers that is pluggable and supported by any system that assigns the dial tone identity. And then based on the dial tone identity during init, a secret provider gets unlocked automatically, abstract to the pod initialization or what have you, and then provides access to other long-lived secrets. And it could be up to the secret provider to control things like key rotation or where the secrets are actually stored, do auditing and so on, but provide us a similar abstraction to all key providers. One thing that was discussed was a temp-fs file system that just expose the secrets as file system object, while the secret provider actually remotes it to something like Vault or KMS or what have you. The advantage of the approach is that then short-lived secrets are the downtown identities, which go away when the process goes away, and long-term secrets can be remoted to a strong key store, a strong secret store.
I don't know that I disagree. I think we need to be really careful about how we, like, and this I think is interesting, is do we want a very flexible system? Do we need a good enough system that can be used, that can be replaced with something more flexible? Or do we want to build, like, for instance, Kubernetes will have flex volumes or container native storage at some point. We know that on the node level, we want to have an abstraction that makes people plug things in. It doesn't necessarily have to be standard, but does allow people to solve problems. Where would we draw the line between we're going to go build the perfect system or a system that can be used to build everything else? Or should we focus on having something simple, bedrock, that can be relied on everywhere to then build integrations that go do more complex things around it? Because I think that's a little bit of the tension I'm hearing in the question, I think, is what should we actually build in terms of flexibility in Cube in the short term, and what in the long term do we think should exist? I think we would kind of like to bias towards doing less in Cube and more around Cube, but have something simple in Cube that just works everywhere.
I think what you're suggesting makes sense in an approach of batteries included, meaning have a default provider that just works. But at the same time, I would think that providing extensibility for pluggable secret providers will be important for Cube adoption in enterprises where secrets might be very sensitive and they might want hardware-backed key storage and so on, or external auditing on who accessed the secret.
Yeah, and I'm kind of biased coming into this because we've talked a little bit about, we have a mechanism with flex volumes that is directly intended to be, here's how you extend the volume mechanism in Cube. And so the way we've always thought about volumes is a secret is just another type of content that's added into a container. And volumes and storage and all that do have lifecycle semantics that have to be managed. They're not quite as actively managed as secrets might be. So like I think I do come in with a bias of we've at least talked about content that gets injected into a container is basically all the same, and it can leverage like the things that content injection process extension needs are requirements on Kubernetes to say, if we wanted to say a flex volume can define the life cycle, or there's something that should exist that says this is just a flex volume problem, and I'm using flex volume as stand-in for however it evolves. It's alpha today, container native storage will eventually exist. It's a similar type of pattern. If we said out of the box we will have a default flex volume or a default volume plugin that does something simple and everything else could be implemented by a flex volume, would that be sufficient? Or do we need to go even the next step, which says, because I do think like we might struggle to reach, like I don't think we want to reach a full design of a full identity management system in Cube. If we prototype out of Cube and then come back, we can always work through that process of saying we can integrate existing identity systems through the flex volume mechanism. Can we prototype what we think of as one or two core systems, and then after we've prototyped and proved the concept, talk about it like the design first as a core system in Cube versus the can we build an extension that proves the concept and then improve the extensions system, etc.
I'm gonna say, yeah, I agree with Clayton. I think the extension points are almost already there to implement a lot of custom kind of secret providers with flex volumes. The other thing that's valuable to me is sort of what's valuable about the way service accounts work right now, which is that they are there by default, and every tool that anybody's written that needs to access the Kubernetes API just works in every cluster because service accounts are always there, specified the same way. So if we can address the weakness that service accounts have right now, which is that they are bearer tokens that are only good for the Kubernetes API, and we can extend that so that they become a credential that's generically useful for authenticating in these other use cases, but keep that property that it is like just something that you can expect by default, and that's works out of the box without configuration. I think that would be really beneficial.
But the challenge with that is that you're solving a certain secret problem, which is the identity of the running pod. An application running in that pod might need access to other secrets. Like, to give you two use cases, one might be database credentials, and another one might be, let's say that I'm running in an Istio-enabled Kubernetes cluster. The keys that are used for Istio for mutual auth and wire encryption might be different than the identity you want to assign to the pod. So wouldn't it be useful for us to generalize the implementation so multiple secrets could be made available during initialization?
So it depends on what you mean by generalize. I would say we should generalize, like we've kind of leaned toward this in other places, which is we've explicitly said we're not going to take features to services, for instance, but you're happy, it's totally possible that someone can go build an extension that replaces the service mechanism. Should we look at it as, it should be possible, like the service account token can't be broken. It has to keep working. It's an API compatibility thing. If we introduce something novel that you have to opt into, but is backed under the covers by one or more implementations that are basically completely opaque to the application, the same mechanism that allows us to do that, to do even the identity level thing, could be the same mechanism that allows us to do the plugins for those or the alternate implementations. Like I would say we've leaned a little bit away in Kube from saying we're going to do one code base with like 3 or 4 Go plugins, because that has a project level limitation. If we instead said, could we define a node level thing that makes available to pods to pod plugins or extension plugins as pods come up, some information, and then build on top of that so that there could be multiple of those. That might be a mechanism where we could prototype and prove out the concept without requiring either a particular implementation and encourage forking over, and I say forking, but like we've definitely found that having an implementation that's fairly whole, that can be easily adapted to new purposes, is often better in a project like this than building a bunch of code plug points that everybody has to collaborate on. It doesn't mean we can't go do that code point that we collaborate on. It might make it easier for us to go through that prototyping phase without settling on that. Because like the batteries included, mix and match implies that the battery can be completely removed and it's still possible to keep ticking over. The service account token has to be there if we introduce something novel on the node that injects something. Could we do it in a way that doesn't require it to be there for the vast majority of applications and instead selectively replace it? I don't know, but maybe.
So,
go ahead.
So I think to kind of try and unify those two things, and talk a bit more specifically. So like in Mark's kind of view of the world, and so aligning those two things, it sounded to me like there would be, say, a Vault flex volume plugin that would automatically get you a Vault token that lets you talk to Vault. And then you would use Vault to unlock whatever other secrets your application needs. Mark, does that kind of fit with what you're describing? Like, I'm using specifics and a specific product there, but it could be any secrets provider.
Yes, to an extent. I still let me play something and tell me if it makes sense to the group. Like in my mind, the current implementation of Kubernetes is kind of there's two pieces. There's a bootstrap identity, meaning who's asserting for the pod identity, and in today's service account implementation, kube master asserts. We don't really, I think, say somebody else might assert and provide an external identity proof. And then the keys that is provided to the pod as a service account is really a default provider that Kubernetes needs. I think what I was suggesting is to say, well, the assertion might be externalized using an identity provider to a Kerberos ticket or maybe an auth in Google Cloud or what have you on Azure and AWS. And then when the pod gets initialized, that's passed in. And by default, it unlocks access to the Kubernetes service account credentials, but it might unlock access to other stuff, specifically, in your example, Greg, the Vault Flex volume. I think what I'm aiming for is to have multiple providers in the node level that can be unlocked by the initial identity.
Yeah.
I understand the point that Kube must be there as a default provider and is not remote.
So I think we actually are, I think we may be even lucky here is that there's nothing that actually prevents there being a node level agent that makes, like, I would say those kinds of plugins, you're right. We want, if there's two options. Kube has no knowledge of container identity, or Kube does have knowledge of container identity. I think we'll probably end up in a world where Kube does have a knowledge of container identity, specifically because of service account tokens. Because I don't actually see a path forward for service account tokens that doesn't seek to constrain them in a totally opaque way to clients so that they are tied to a pod's instance versus not, right? Like just like natural evolution, like we can't ever remove service account tokens because they're part of the V1 API. They're basically something we deal with. And so like working backwards from that, I would say, I think it's very likely that Kube will do something at the very core levels of Kube that exposes some sort of identity that Flex volumes can get access to that may not be exposed to end applications except through Flex volumes, right? Like that might be a natural way to prototype this. And if what we need to do is, maybe say, if we have 2 or 3 Flex volumes of different provider types, like a Vault type or an EC2 type or whatever the node agent is, we could absolutely spec whatever we need to do to prototype the core Kube container identity in a flexible way, and also make it available to those other Flex volumes so that we can prototype Vault and Spiffy and other types of integrations that tie together. Like and this is almost a mechanical point that I'm making, but I think it's important from the perspective of we don't want to be opinionated as much as we want to be able to effectively let you drop. Like if we could use a mechanism like that to prove that this works, that means that everybody who builds on top of Kube will have a plug-in mechanism in place that they can build other types of things that are equally as valuable as identity and secret.
That makes sense to me.
I think it might be worth sort of starting with like what's there now, like kube.iam and some of the Vault controllers that are out now, and sort of what don't we like about them from a security perspective, and like where are the weaknesses that don't let them work the way we want with Flex volumes today.
Can you please maybe educate me, and I apologize if everybody else knows that, about the properties of a Flex volume? Because one thing that was brought up by one of the banks when we were talking to them 2 weeks ago was the wish that when we expose the secrets into the pod space, they won't be persisted locally, but rather the calls to the Flex volume will be remoted to something that is externalized, let's say, to Vault, rather than injected and persistent, even in memory, in the pod namespace. So I'm not sure how Flex volumes work today.
Jordan, you were looking at some of this?
So Flex volumes basically get the ability to mount things into pods. So you could mount something that appears as a file system like NFS into the pod in such a way that the data never actually lives on the node. And so file system calls would get translated and actually set aside remotely. That's a possibility. I haven't actually seen anything do that, but I mean, the same way you mount an NFS share and you could mount something else in so that the data actually still lives remotely.
And they can also be used to mount a Unix domain socket to expose a workload API.
Yeah, I mean, mounting a directory, a file, a socket, it has the ability to do all of those things.
And like on the work that was going on in the 1.8 timeframe was to make it easy to make new flex volumes be containerized and let them, run them as a daemon set and allow them to be available for Kube. Can anybody talk to that? I was there at the beginning of the discussion, but I haven't seen the latest.
The poll is I think close to merging. I know the Rook team has been building on top of that poll, kind of proving out the concepts and actually have their Flex plugin working through a Unix socket. So the dynamic deployment and pickup of Flex plugins, I believe, is still on track for 1.8.
So I do have maybe an implementation question here about how we envision this to happen. So I think there's a tension between an application would prefer to have, if I'm a developer and I run on Kubernetes, or if we can extend this beyond Kubernetes, to have something that I know is there. Like, for example, I know if I go to /secrets, then my secrets are there. And then that could be backed by multiple things. On the other hand, we want to support multiple providers. So I think my kind of question is, do you guys envision a single flex volume provider for secrets that can be backed by multiple providers, or do we envision each provider implementing their own flex volume, and if so, would the namespaces be different?
So today in Kubernetes, the only reason that you have a service account secret at var run secrets kubernetes.io/service account, I think I got that right, is because there is an emission control plugin, effectively an initializer, that adds that to every pod. So one of the things that I think is reasonable for us to discuss is, given the initializer mechanism available in 1.7 and 1.8, which still has a few things that we need to go fix, I don't see anything that would prevent us from replacing that in a clean way to let an initializer run that adds a flex volume to every pod on the cluster that completely replaces the implementation of how service account secrets are delivered, or adding additional ones, just like pod preset has been proposed, or the Istio container. Like, injecting a volume is no different than what we're doing there today. And so in theory, whether it's one flex volume or many, I would kind of expect that we have a default service account implementation today. It just happens to be drawing on the fact that there is a real secret there. I would like to replace that with something that follows like the next best Kube pattern, and replaces, service account token injection from a secret with service account token generation via flex volume on the node. And I think it's very likely that we would probably want it to be very easy to take those and customize them, so that there might be like a core bit of code, which is like the controller framework in Kube, which would be like a flex volume framework that you could easily extend. There might be a secret one, or a service account secret one, that could be easily extended. And we could do the code level plugins there if we wanted to. But I do think that it should be easy to say, at a cluster level, I want every pod to get this flex volume injected at this path. And to do that, like, I think we have almost all the tools we have today we need to go do that, which would allow us to basically say, oh, you want a vault token located at var run vault / private key dot key. Just add a flex volume that implements that, and add an initializer that adds it to everything. And you can, it's just like operators and on top of Kube extensions with custom resource definitions. We should be able to do the same thing for service account tokens and secrets.
Yeah, I would expect each one that you want to be injected injected to have its own initializer and volume plugin that accomplish that, and for those to probably be built on top of a common bit of code that's going to look very similar to what we do for service accounts. So I think modeling them as distinct, but letting them kind of take advantage of the work that we do to prove this out for service accounts.
That makes sense. Just one follow-up on that. Do you envision each of them having a different file system path, like for example /vault and /kms? How do we envision kube abstracting /secrets and having the key provider provide the secret provider provide secret into that single path rather than having the application understand who's the secret provider? Like, we can go both ways. I'm just asking.
We've talked about this. We kind of regret. So the part of the reason it has the downward API is to require it to be explicit what magic APIs exist inside the kubelet or inside a pod. And today it is explicit. It's just auto-generated. People rely on it. I think it's totally reasonable for people to be able to replace the service account pattern as long as you obey the API contract, replacing it with whatever you want. As a concrete example, for instance, in OpenShift, we inject additional CAs into that secret by updating the secret in Kube. We would like to switch to a model where we inject those additional CAs via a flex volume and simply replace the emission logic that puts one secret in for emission logic that adds those additional CAs. So does that answer the question you were getting at? I'm not positive that you and I were talking about the exact same thing.
I think it touches on the question, but not fully addresses it. My question is really about the developer experience. So let's say I'm running application foo, and it gets initialized in a pod. Do I need at that point to know who's my secret provider and read from the file system path associated with the provider? Or do I always go to /secrets and whatever providers are configured are materialized there?
I think it's more about use. So if you're expecting to get the token to talk to the Kubernetes API, right now that's injected at a well-known path. I think if something wanted to replace that and give you a token credential to talk to the Kubernetes API, like that would be where they would put it. If you're going to get a Vault token, well, you're probably not going to look at the Kubernetes API token, right? So either the Vault token provider having a well-known path, or doing something in combination with injecting the volume, like setting an environment variable to define it. It has to be communicated some way, and I think it's more about use. Like, what is the container going to go do with this credential? I was
going to say, I think there's a really broad question here, which is, is this group of people desires to define a convention that every application that runs in a containerized environment on top of Kube might use? And I think the answer is it's legitimately within the remit of this group to suggest something like that, getting people like SIG-apps involved, right? Like, the point of the service account token, even though it was somewhat we might somewhat regret how aggressively it's been used, before RBAC landed in Kube, et cetera. But in practice, it means that a cloud native application can look on the file system, get a credential that allows them to see the world around them from a API point of view, which is really powerful for infrastructure components, and in the future will be very powerful application components. Coming up with a similar convention that not everyone has to adopt, but most Kube distributions use, could well be within a suggestion we make. There's two types of identity in Kube. There's your service account token, and there's a private key that you're given. If the private key is not there, you probably need to gracefully fall back. But I think in practice, if we can convince ourselves that it's something that most people on Kube would want, we could define a convention like var run secrets kubernetes.io /identity /id.key and id.cert. That might very well be reasonable. So I think to that angle, we should discuss it and see if we could come up with something that makes everybody's lives easier. Another one is the TLS, like serving certs. The vast majority of applications in the world want serving certs. Whether that's implemented by a proxy outside of the container or inside the container, there's probably use cases for both. This group, or Big Apps or another related group, defining a convention for where TLS keys get injected, even if it's still required that, like, your app do a little bit of work, might smooth the path towards all applications being secured on Kubernetes all the time, which is a great goal.
I think one of the important keys there is that, like, the experience is consistent across clusters, right? Because, like, right now, if you are writing an application that will need to talk to a Kubernetes cluster, because of what we've done with the service account tokens and whatever, you kind of know you can deploy it on just about any cluster and it will work, right? And so, like, preserving kind of that experience where you don't have to be like, oh, this is how it works on one cluster, and if you want to use it on a cluster that uses this other system, then you have to do this thing. Trying to preserve that kind of feel, I think, is somewhat important.
I totally agree, and I think this is one of the failures right now of sort of like the TLS ecosystem, is that there aren't conventions for where do you get your cert, or even where do you get your trust store. It's different on every Linux distro, and there's not like a conventional path. Making it so it ends up every piece of software has like these set of 12 configuration options you have to set to specify all the TLS parameters.
And a simpler example might be, it certainly seems reasonable that someone on a cluster-wide basis would want to define what their trusted CAs for. There's nothing that prevents a workload plugin or a flex volume from potentially looking at the images prior to start and saying, where do I put certs in this? Like, whether we define a convention or whether we fit into existing OS conventions, or whether we give people the tools to, lay down the hammer and say, thou shalt put the CA trust bundle at Etsy, cert SSL whatever, or Etsy TLS private whatever, like, giving people the tools to do that and being open to having those kinds of out-of-the-box defaults. Like, we're very close to having that, right? Initializers, flex volumes, and secrets are all roughly within the ability to go do this. This group kind of going through those ideas and prototyping them and having a mechanism where we can kind of iterate will be very important.
I think it would be extremely powerful for us to suggest a standard convention, because I think it will make application developers' life much easier. And it also, a use case that came up last week from a customer was they want to switch key providers. Like, today they use I'll say SafeNet, and they want to switch to Vault. They don't want to rewrite their entire app stack, which is hundreds of apps, to figure out how to talk to Vault. So if there was a standard abstraction whether you can just switch the key provider and it materializes in the same place and it's the same key just backed by somebody else, that would have saved them hundreds of man hours.
Yeah, another example for that is our application in different environments. And people have, secret stores for their staging environment sitting in one location with one type, and their pod secret store may be in a different location, a different type. And rewriting the application between staging and pod environment is quite a pain.
Yeah, I feel like a really good point here to bring up too is, like, there's a spectrum between organizations that are capable of dictating convention and organizations that adapt existing software into those. And so there'll always be some spectrum of, for instance, like, I think this is like when we talk, like when Google talks about like common libraries, there's a great example of Google mandates by fiat that internally everyone shall use these 3 libraries in this order, depending on, how things work. And that just doesn't exist in a lot of the enterprise environment. And then people coming in like startups or building, cobbling together applications, a lot of people look to say, well, I've got to take these existing applications and adapt them. I need the tools and primitives that let me tweak those, right? So we have the ability to put service account tokens at a consistent place, that things that the Cube team or ecosystem people build and look at automatically. But there'll always be those things where you need to set the flags, and we'll always have some spectrum there. We should think really carefully about anything we build that's opinionated is still flexible, in the sense of we don't mandate that you have to adopt this to find the benefit, but that you can adapt applications to run them in the containerized environment, kind of in a traditional sense, and slowly adapt them to pick up the patterns. Because usually, like, a lot of people, like Downward API does that with environment variable adaptation. We put the files on disk, but not everybody reads the files. Not everybody can read a labels file. Templating of config, like all of these kind of fit into that same pattern.
Yeah, and I think there's also, you know, a backwards compatibility client libraries aspect to this. So I think you know, even if we are opinionated about where things live, I think, you know, the existing Vault libraries or the existing Google libraries or whatever that are expecting things to be in certain places, we might have to put them in those places, but maybe there's some sort of fallback mechanism to whatever the opinionated container Kubernetes standard location is that eventually makes it into those client libraries.
Mm-hmm. One thing that I did want to raise, and you know, I'll defer to the group, is ideally from an Istio standpoint, we would love to be able to reuse the Kubernetes implementation and provide the same, even the same code if possible, in Istio when it runs on VMs. So I was wondering, is that a reasonable goal for the group?
I think so. I think the convention that we're talking about where do applications look for their credentials and their identity, there's no reason I think that needs to be Kubernetes specific. I think we're in a good position as a group to define it and push a standard.
Well, I'll always I'll put my graybeard hat on and say I've seen many of these well-intentioned conventions run ashore on the rocks of reality. Sometimes, like, even looking at service account tokens, we didn't get those right initially. And, you know, thinking about all the challenges we've gone through with the kubeconfig in cluster config, it is actually, like, those are an API that have to live forever. And so one thing that may make sense would be we should think about establishing these patterns and show examples and demos in a compelling way that demonstrate real value of the standard, and use that of having a convention, and use that as the club/carrot that you know, get people along. So like the Istio example is a great one, right? If Istio can look at a convention that's reasonably there, if someone can take an existing Vault plugin and use it, and it, you know, show it in those 3 or 4 steps that goes from, you know, oh, this is really hard, to, oh, I put these 2 pieces together, use this extension thing, and suddenly I have access to a Vault. Like, each one of those scenarios showing to someone provides the value, and, you know, we can maybe standardize what works after we get more experience with it. Like, I'm not like, I think it'd probably be a good idea to quote unquote standardize it, but I would always be cautious about, let's standardize or conventionalize something that's been proven to work versus dictating up front.
An example of, I think, an ecosystem that is doing this relatively well right now is AWS tooling, which almost universally works without any configuration if you run it on an EC2 instance that has an instance role attached. There's almost never any kind of manual configuration of anything that needs to talk to AWS.
And I think if we should look, we definitely want to get to that point where each of the cloud providers can have like a first class integration for this that ties into their, like, and I think this was called out in the issue or in the doc several times, was being able to trade on the identity of the node through the cloud provider's existing identity system will be very powerful if we can, you know, do it in a clean and flexible way. And then we'll, you know, try to have the equivalents for non-cloud environments. And if the conventions are roughly similar, application workloads will work really well.
Yeah, one thing I did want to bring up in terms of the mechanics of this convention, we've been talking about sort of file system paths, which is how service accounts work right now. The other mechanisms that kind of come to mind are link local network interfaces, network APIs, and or Unix socket APIs are kind of in that same bucket, or environment variables. And so environment variables are kind of out if you want to do rotation. But then the other two options are both vulnerable to either like local file disclosure vulnerabilities or server-side request forgery vulnerabilities. So like there's some trade-offs I think we should think about and be explicit about choosing a file system as the convention.
I do think that. So my only comment was when I said file system, I actually meant in memory. Like I don't think we should ever persist those things.
Yeah, but even in memory, if you have an application that has a vulnerability where it'll read from the local file system and return to an attacker, it doesn't matter whether it's reading from in memory or whether it's reading from like a fused file system that's not even persistent memory. Basically, if the application is reading from a path on disk, there are vulnerable applications that will expose that to attackers potentially.
If you compromise the app, wouldn't anything that the app can touch is compromised anyway?
If you're assuming like a total compromise, like remote code execution, then yes. But there's sort of these categories of lesser attacks that you could potentially harden against. So this happens in AWS with link local credential service they have too, where you can there's a class of attacks on real applications where you trick a server into making a request and proxying the result back to you. And if you're running on EC2, that gives you whatever credentials that node has. Just brainstorming, like things we could do to harden that is, it's kind of tricky to think about. Like we could pass in a non-rotating token via an environment variable, require that token to be used against the local API. I don't know. I'm honestly not suggesting necessarily that we don't use just file system paths, because I think that's the easiest route forward with flex volumes. But I just wanted to bring up the topic.
Yeah, and I mean from an application developer perspective too, like there is a reason we talk about file system paths a lot. Like, right, getting application developers to use them or teaching them how to use them is pretty easy. Like everybody knows, oh, you just open this and read from it. Whereas, not that, network, link local network or Unix domain sockets are a little bit harder. But, obviously for Unix domain sockets, you have to explain to some people what a Unix domain socket is. And, it's not quite that level of open and read. As file
I think
system.
a good litmus test is whether you can interact with the system from like a bash script.
Yeah, exactly.
So we're coming up on the hour. Greg, what kinds of topics do we need to kind of close on for this, and what goals do we want to set for the next meeting?
Yeah, that's a good question. So perhaps the goals and use cases should still be the focus of like where we're trying to formalize. So let's try and get some more comments on those and look to put the goals into the community repo somewhere. And then next meeting, I don't know, where do we want to go from here? What's the next decision point? I'm actually not sure.
So today we spent a lot of time. I think that we did a lot of fleshing out the node, secret injection, how to tie things into a running workload via flex volume or things like that. And I think that the first half of the problem, that customizable identities from different providers, is still we didn't spend much time on that. I think it would be good if we can discuss that part in the next meeting, whether we can reuse the authorization plugin model, or if there's identity exchange model or some other ways where customer can inject like a Kerberos or AD identity into Kubernetes.
So there was a lot of talk about flex volumes. I wonder if should we get someone who knows the Kubernetes flex volumes to come talk to us, maybe? That might be a useful use of our time.
Yeah, especially someone who may or may not quote unquote own or be responsible for, so that like it's a clear, hey, like we really want to use flex volumes and we know that there's CNS coming down the road, but the use cases are very clear. Kind of going through that discussion. We kind of have some use cases in the pragmatic sense. Certainly we should all know about it, that's for sure.
Yeah, okay. So I'll talk to, I guess, Saad on the Google side, and he can probably help identify. If he's not the person, then he can help identify the right person to talk about flex volumes, and we'll get them to show up to the next meeting. And Clayton, I don't think you made the meeting recurring, but I assume it's supposed to be recurring at this.
It is, unless people find that they can't make this meeting, but I think given the 40 participants we had here today, that we'll just go ahead and make this recurring.
Yeah.
Is everybody okay with that? Like, I'm sorry that this is at 8 o'clock for the West Coast, but it is 4 o'clock for Europe.
On a Friday. Yeah. Yeah, let's do that. I think we don't want to relitigate the deciding on meeting times again.
Okay, I'll go ahead and make this recurring then.
Okay. All right, so I'll organize someone to speak to us about flex volumes, and yeah, we'll try and set an agenda a few days out this time rather than like 5 minutes before.
Hey, Greg, I have a quick question. Do you know what's the state of identity provider for administration right now in Kubernetes? Like,
what do you mean?
So when I do, when I make an API call against the Kubernetes API machinery, can I be authenticated against an external identity provider?
Yes, you can.
Can anybody in the next meeting speak to how that works? Because perhaps we can reuse that for the Bootstrap identity that Sandra was mentioning.
We've done a lot of development against the plugin system, or at least against the OpenID Connect stuff. I actually have specific concerns around that model because it's been hard for like applications running on top of Kubernetes to assume a specific one. So if people find that relevant, then I can chat about that.
Yeah, okay. So talking about OIDC and maybe how that pattern is not been working.
Yeah.
Yeah, I had ran into the same thing over the last few weeks with the Kubernetes dashboard and also Tiller from Helm. They both have these kind of problems where they want to authenticate a Kubernetes user. And right now they work by just taking the Kubernetes credential and assuming, anyway, it's pretty imperfect.
Okay. Okay, that sounds like plenty of stuff for the next meeting.
Thanks for organizing this.
No worries.
Thanks, everyone.
Okay, I think that's it. Thanks, everyone.
Thank you.
Thank you.